All right, we're moving on to inverses of matrices. Our essential question is, can you solve systems of equations using inverses of matrices? We actually did this a long time ago, but I'm going to give you the formula. Well, we solved systems of equations using inverses, but we're going to learn what inverse is and how we can apply it. So if A is equal to A, B, C, and D, and we know that the determinant of A cannot equal 0, then the inverse, which is signified with that a to the negative first, is equal to 1 over the determinant of A. We did that yesterday. And then notice that we scalar multiplication, and we have D, negative B, negative C, and A. So notice the D and the A switch. Let me just show you here. The D and the A switch, and the B and the C become negatives. So that's the little formula that we're going to use. If the determinant of A is equal to 0, so if the determinant of A is equal to 0, then it has no inverse. So let's get moving. For example 1, if I have A is equal to 6, 2, negative 3, 1. Sorry, that was the bell. I always wonder if you guys think our bell sounds weird if you're not at our school. All right, so the first thing we needed to do is find the determinant. So remember the determinant, we're just multiplying 6 times negative 1. And subtracting it to 2 times negative 3. So 6 times 1, did I say negative 1? Minus 2 times negative 3. 6 minus a negative 6 is equal to 12. So to find the inverse, we are going to take 1 over 12. And remember the 6 and the 1, we're just going to switch. And the signs of the others, we're going to switch. So the inverse of this is 1/12. Yeah, I will get weird numbers. Negative 1/6, 1/4, and 1/2. So I actually simplified as I went. So hopefully you know you're taking this 1/12 and you're distributing it, scalar multiplication, through all of these terms. And that is what the inverse is. Not a hard concept, and I think you guys are going to do great with it. So remember when we did the solving systems of equations, we did 3 by 3. So I'm going to find, I don't even know if I have a 3 by 3. I guess we'll do a 2 by 2. I'm kind of looking through the book right here, and I don't have a 3 by 3. So let's do a 2 by 2. If I have example 2, 2x minus y equals 6, 3x plus 2y is equal to negative 19. Now, I probably would not solve this using matrices. I usually save that for 3 by 3s. I'd probably multiply the top 3 by 2 and cancel out the y's. But let's go ahead and set this up in matrix multiplication. So remember, we're going to put it in as a 2 by 2 using the coefficients of the x's and the y's. So I'm going to call this A in my calculator. And then remember, to find B, I'm just going to take the answer column. So we're going to put this in on our calculator. And remember to multiply using inverses. I'm going to take the inverse of A and multiply it by B. So this is what we would put in our TI-84, and hopefully you remember how to do that. If not, you'll have to go back to another video of how to put matrices in the TI-84. Now, what if I had to do this by hand? Okay, if I had to find the inverse of A, I am going to take 1 over the determinant. Well, let's do that really quickly. I have 4 minus a negative 3. Well, 4 minus a negative 3 looks like it's going to be 7. And I'm going to multiply that. Well, the 2 and the 2 switch, which doesn't change anything, and the 1 and the 3. All right, I'm coming back. I had to erase a little bit because I forgot this negative right here. Remember that negative, so I have to change the signs of the B and the C. So the negative 1 is now 1, the positive 3 is now 2. From here, we're going to multiply by 6 and negative 19. And let's go ahead and multiply here first. When I do that, I end up, because it's a 2 by 2, multiplied by a 2 by 1. It's going to end up being a 2 by 1. So let's multiply the first. 2 and 6 is 12. 1 and negative 19 is negative 19, so we do get negative 7 there. And on the bottom, I get negative 3, and 6 is negative 18. I think I have to write that one down. And 2 and negative 19 is negative 38, which gives us a negative 56. So when I use scalar multiplication here, I get a negative 1 and a negative 8. Now, I am not saying that this is the easiest way to find the answer to these in example 2. If it was a 2 by 2 or a system of equations with just an x and a y, I would probably just go ahead and multiply the top all through by 2 so the y's would cancel out. But it's always a good option, and it's great for a 3 by 3 on your TI-84.